appreciate that. My job is to connect and convene people, and I'm always satisfying when we're able to do that. Yeah, so if you need a connection in one of these worlds, or you see somebody here that you would like to make sure to have a chance to follow up with, that's our job. We keep our email list to a crisp 4,999 members, because the next tier of pricing in our membership software is at 5,000. But that really keeps active people, and it's quite a group within Maine, the largest energy and environmental community. If you're not a member now, please do join. And part of the magic is that everything we do is free for students and elected public officials, and you joining helps us keep doing that. That lets us be that impartial roundtable to take on the issues of the day, including increasing the diversity of the sector in which we work, which is hard work, but we are progressing and working all the time. I just recently worked with an engineer to help him get a position at one of our member companies, and he's off to a great start after re-credentialing from a career in Burundi. So that's kind of neat. And we are pleased to work with MTI. Do you have a project for MTI to look at, to fund? It doesn't have to be a startup. It can be a new branch of your existing company, a new idea, something different you want to do. MTI wants to help you innovate here in Maine. Let us provide some concierge service to make the right introductions over there and run through their assessment, or just go to mainetechnology.org and click that Ready to Start button in the upper right. Please get involved with MTI, a remarkable program. These companies support us all year long at the sustaining steward level, and this is $2,500 a year, and it really just helps us keep what we're doing. We're a small nonprofit with a staff of 2.5 people, and a budget of about $180,000 a year. So everything that we do is funded by these companies. And then I always like to linger here because this is the $1,000 level, and we appreciate these companies. Many of these companies have supported us for 10 years plus, and it's wonderful that they do that, including, I'll just highlight Party Flaherty. So thank you to these companies. We aren't, we're a membership driven organization, and these are members that really step up, and all of you are members. And then TRC and VHB all year long sponsor all our events as well. Thanks to them for doing that. Would you like a free print subscription to Maine Biz? Just send us a note afterwards to info@e2tech.org, and we'll fill out the little form, and it genuinely is free. You'll get Maine Biz in the mail every week for free. It comes out promptly and is full of interesting Maine news. They do a good job. So in a second, I'll be handing over to our host, Paul Williamson. This is actually not true. Your mic has not automatically been shut off. You turn it on and off. We're trying to generally connect. It's called E2 Tech Connect. So this is a little interactive thing that we're doing. We are recording it. Paul will direct how he would like questions to come in. And if something isn't going the way you want it to, email Riley or me there, as you can see. And these events, we try to have them hosted by an E2 Tech board member. And we've got a perfect one for this topic, that's for sure. Paul Williamson, who's senior developer at Key Capture Energy, has a long legacy of work in offshore wind here in Maine. So Paul, thank you for hosting today, and I'll let you introduce our panelists and give a quick note about Maine's offshore wind process and take away the remainder of the program.
Thank you, Marty. Thank you, and welcome to everybody who was able to join us for this afternoon. As noted in the title, we'll be receiving an update on the offshore wind market in California, as well as making some comparisons to the Maine market and both what is similar and also what is different between the two markets. We could go to the next slide, Marty. Just as a real quick note, because we are going to be focusing on the Okay, I will go sorry, I got myself a little bit out of order here. But we'll go to the introductions for today's speakers. Today, with us, we have Scott Hodgdon. Scott serves as the project manager for 1898 and Company, which is a part of Burns and McDonnell. In this role, Scott manages and conducts planning studies that are conducted for generation and transmission developers, utilities, and regional system operators. Prior to joining Burns and Mac, Scott worked with CAISO New England in various roles in system planning and market monitoring. He holds a bachelor's in electrical engineering and a master's of business, and he is based out of Portland, Maine. And also with us today, we have Milad Arouni, and Milad serves as a manager for transmission and distribution projects with a focus on emerging power markets for Burns and McDonnell. Milad provides consulting and engineering services with more than a decade of experience across the renewable energy and electric infrastructure industries. Milad has a master's degree in mechanical and industrial engineering from Ryerson University in Toronto and a bachelor's in electrical engineering from the University of Toronto. And with that, we'll just take a real quick look at the current process here in Maine. We are going to be focusing most of this conversation on what's happening in California, and as I said, some comparisons to Maine. But we did want to start off the conversation by illustrating that there is a current process set up for both the exploration and the continued development in Maine. And you see here the timeline that carries us through to the end of 2023, and then BOEM activities really starting to ramp up in 2024. And so this slide here does illustrate this. And if anybody wants additional information on that, they can come back around after the discussion and connect with E2Tech on that. And with those introductions, I'm going to go ahead and hand this over to Scott, who is going to start in on the presentation about the California market.
Great. No, thank you. Can you see my screen okay?
Looks great.
Yes, we can, Scott.
Excellent. All right. Well, thank you for having us here. And, it was a great intro. So, not much I have to do to tee this up. But here we are today. I want to talk about kind of the California offshore wind market and, make some comparisons to what we have here in Maine. So just quickly walk through here. You saw our pictures and you got the intro of who we are. So Milad and myself will be giving a presentation. Milad is on our west coast side of the U.S. and I am right here in Portland, Maine on the east coast side. So we got both coasts covered. Here at Burns McDonnell, one of the things we take very seriously is safety. So I always like to start all of our meetings with kind of a safety moment. Here we are kind of in the dog days of summer. So the heat is definitely on as it was this past week. So just want to take a moment to remind folks, take it easy out there, wear sunscreen, drink plenty of water, sip it slowly when you are drinking, take breaks as you needed, stay in the shade. Really, want to do what you can not to become overheated and, have any suffering from heat exhaustion or heat stroke. So very, very relevant to this time, especially given the last week that we had. Please stay safe out there. Here we go is just a little agenda as far as who we are. We'll go through that. We'll give a little overview of California, what's going on over there, kind of how we've gotten to the point where we are now, where they have some lease areas proposed out there, and we're in the process of starting to really, develop bids and things like that nature, which would go into those lease areas. Some issues with offshore wind and some deep waters that we just want to touch on. That's really the big linking point between the two coasts of California here in Maine, and obviously on that with some comparisons to Maine. So as far as who we are, Burns McDonnell, we are a architecture, engineering, and consulting organization. We have many activities in construction design and consulting services supporting a variety of industries, pretty much worldwide. We have offices, I think, nearly in every state of the U.S., as well as many other countries throughout there. What we like to say is we are located where our clients are, and we're right there in front of our clients whenever we need to. As you can see from this slide here, we have a pretty good success in terms of the different industries that we work in. And we're up to more than 10,000 professionals, 100% employee owned. Headquarters for our company is actually based out in Kansas City. In particular, with our involvement in offshore wind, these yellow circles here on the slide kind of indicate where we have service capabilities. And you know, it used to be more of just on the dry portion of everything here. And you know, the past few years we have been getting more and more involved in the offshore part of this. We have offshore substation subject matter experts. We have offshore cabling subject matter experts that help in these consulting services. And really now we've been able to cover everything, you know, from that transition piece, from the wind turbine itself, all the way to the grid connection. So this has really been great in terms of seeing how all the different pieces connect, align, and really how you get from point A to point B in this whole project development process. The other thing I just wanted to quickly touch on is, you know, 1898 Co. We are a part of Burns & McDonnell. I am still a Burns & McDonnell employee. 1898 Co. is really the consulting arm of the business. So just want to avoid any confusion there. That's what we do. And this is kind of that transition. So 1898 Co. is really a throwback to when our company was founded. And what you can see in this slide here is that as the industry has evolved, you know, there's been more and more needs for, you know, this consulting arm to be branded, and that's when we took shape here in 2019. And myself, this is maybe a little you know, what I do here, but I'm more in the utility consulting services side. So really what I like to call a system planner, dealing with distribution, transmission, generation, and project development. You know, this is one of the many services that 1898 Co. and Burns McDonnell can provide. But obviously, just wanted to kind of give a quick highlight that, especially as it relates to the power industry. So with that, I will turn it over to the West Coast and let Milad give an overview of what is happening out there in California.
All right. Hello, everyone. It's a pleasure to be here. Appreciate the folks at E2 setting this up for us. Wanted to kind of give you guys an overview of what's happening on the West Coast and with California. And for us to really do that, we need to kind of start from the origination of, you know, where the demand came from and where we are and how offshore wind kind of plays all into this. So many of you already know California established the legislation back in 2016 to reduce their overall greenhouse gas emissions to levels back in 1990. And some of the goals that you guys can see up here is about 40% of that is slotted for 2030, which is fast approaching, and then 80% by 2050. Additional to that, the state has legislated to make sure it's carbon neutral by 2045. So all of that stuff kind of pressurizes the state as a whole to move towards clean electricity, renewable sources. One of the things that has happened since then, the Air Resources Board, which is a slide you guys can see this with the GHG goals, has identified where all the greenhouse gas emissions are coming from. One of the things that I've noticed is 41% of that is slotted for transportation, and then 24% for industrial. And surprisingly enough, we expected electricity generation to be a big part of that, but it's not. So one of the things that we're working on currently is to make sure that the greenhouse emission reduction of transportation is reduced to the best of abilities, and California Air Resources Board is putting together mandates about having commercial industrial customers, any fleet owners, to essentially electrify their fleet essentially as of 2023. Next slide, please. So in order to kind of talk about what that legislation's impact is, I wanted to kind of highlight here what California's current consumption is. And this slide is actually taken right out of California ISO's daily consumption. This is for July 11th, so this past week. And you guys can see how the energy consumption, how it's trending with respect to the different, I guess, sources. Predominantly, you're looking at, renewables during the solar day, solar hours. And then as you guys can see where the solar kind of peaks, drops off, you'll get natural gas adding and augmenting to essentially the peak load of what is it, about 22 gigawatts of consumption within California. Next slide. So with all of the greenhouse gas emission reductions, the CEC, California Energy Resources Board, has predicted that most of what's going to happen is we're going to be more electrifying our fleets. We're going to be converting more towards electricity to essentially reduce greenhouse gas emissions within buildings, commercial, industrial customers, and all that. And they're expecting about a 60% increase in the electricity and a 40% increase in peak load, which is huge by 2045, and that is on top of the annual growth that we're going to be expecting on a year-to-year basis. So one of the things that needs to happen essentially is obviously you need to reduce your natural gas usage, essentially minimize it as much as possible. So what's happening with that is, and then we'll talk about further studies that have been done on that. But as you guys can see here, where we had natural gas kind of pick up in our current state, right now the plan would be to essentially augment that with battery storage. And in order for us to do that, there needs to have enough generation to be able to store. So on the right, you'll see what the projected new resources are looking like. So we're obviously expecting a huge increase in solar, storage, and then also additionally into both onshore and offshore wind. Next slide. All right, so fast forward out of that, what you guys had seen from CEC, there was a coalition between the CEC, California Public Commissions, and California ISO. For the first time ever, they've actually published a 20-year transmission plan to be and this was solely due to the need that's coming out of California with respect to reducing greenhouse gas emissions. So what they're expecting, what we just talked about in terms of peak load addition, on top of that, they're going to be retiring about 15,000 megawatts of natural gas generation, creating a deficit of 97,000 megawatts by 2040. So that's what really augmented and kind of resulted in what we are seeing right now in California. There's a huge push there to make sure that we are building towards that deficit. The CAISO plan specifically talks about, and I have the numbers out here, they're hoping to add 37 gigawatts of battery storage, 53 gigawatts of solar, and more importantly, on the wind side, they're hoping to add about 24 gigawatts of wind, which is a combination of offshore and onshore here. Next slide. So this is where we kind of dive into the offshore wind piece of this. This is a California, this is again from the CAISO plan. The dotted lines are kind of showing you guys where the transmission pieces need to be added and where the injections are hoping to be. Something interesting out of this is you guys can see there's dotted lines that are kind of sitting in the coast. California is fully expecting some sort of transmission line within the waters, either HVDC or HVAC. So that's something we can talk about a little bit more. But as part of their plans, CAISO had put in, they had allowed for the Humboldt Bay, Morro Bay, and Diablo Canyon to a tune of 10 gigawatts to be added within the transmission and the generation piece of California. We'll talk about also additionally, they were talking about Del Norte and Cape Mendocino, which is not currently part of BOEM's solicitation and plan, but they did include that as part of consideration there. An interesting tidbit: the Governor Newsom of California just recently released a statement to California Public Commissions urging them to increase offshore wind capacity for California from 10 gigawatts to 20. So there is at all levels of legislation within the state, there is push to get more and more offshore wind on here. So what does that look like for us in California with all of this need for additional solar and generation and offshore and onshore and offshore wind? Next slide. So what ends up happening is the California ISO also has identified that the transmission backbone within California is not adequate right now for the required injections. So what they're doing within their plans is actually planning out new transmission lines, new substations, and more specifically, these are the ones that I'm talking about are with respect to offshore wind. So North Coast Offshore Wind is assumed to have a new 500 kV AC line running from Fern substation, and then a HVDC line from Collins to Collinsville substation. Both of those are right now in solicitation with CAISO, and we are looking to see who's going to come out on top with those, and we are closely monitoring that. And then also they're also planning on having a additional substation built, essentially a line from Fern to Tesla. So this is all for the North Coast call area. Next slide. On the Central Coast, something similar also. They're expecting the offshore wind to be connecting at 500 kV because of the sheer power that they're hoping to inject there. And they're expecting a Diablo substation and Morro substation at 500 kV. Each of those areas will be slotted to essentially intake another 3 gigawatts of power into the grid. Next slide. So in terms of where we are currently with that, from the CAISO side, I did mention that the solicitations are out. Developers and owner operators are currently bidding to essentially build those transmission lines. In terms of where we are with offshore wind, we are just about getting ready to go for auctions on the Humboldt Bay and Morro Bay call areas, and which I will show a little bit later. But the more important thing is in terms of an overall process, and it's what you guys can see at the bottom right-hand corner of this slide is we're just in the infancy. So we're just right before the auction, then we got a long way to go. And a lot of this power injection and renewables requirements need to essentially be around for 2030. So we're really butting up against time here with obviously with difficulties that we have on technology. Next slide. All right, so challenges. Obviously scheduling, as I just mentioned, these transmission backbones, especially at 500 kV. I mean, we're typically looking at long-term projects here. 8 years, we're estimating about 8 years to be the fastest that we can potentially move within California to do a transmission project. Obviously, the permitting portion of that is a huge piece, both on the transmission side and also on the offshore side. There's lots of conversations being had by different stakeholders. Department of Fishery is another one of those that we're working very closely with. Port infrastructure and supply chain. So as we are moving forward to essentially intake this massive amount of power, we are taking a look at what ports we have, what large ports we have that are actually able to take in the power, take in the additional space and crane capacity to be able to move some of these offshore wind turbines. And right now, the way that it's kind of set up right now, the ports that are actually slotted to be able to take something like this are more towards Southern California, so it's not exactly ideal. So people are taking a look at the existing ports and their capacities, and even looking at potentially upgrading these ports. The Humboldt Bay, for example, port just asked for a grant for about $13 million to just expand for the specific offshore wind projects that are coming down the pipe for them. To make matters a little bit more complicated, we're going to have labor requirements from each jurisdiction. So the supply chain bits of this, combined with the port capacity, is something we're definitely taking a look at to make sure. We're waiting to see how that unfolds. Obviously, union labor will have a big part of that as well. Technology, obviously, there's a gap. With the floating technology and needing to mature, there's not that many projects out there that there's I believe like less than a handful that are demonstration projects. For something like this to actually work out, we need to get a little bit further ahead. Substation design, same type of considerations there with the depths of water that Scott will go into a little bit later. We are looking at potentially, the challenge has been where to locate the substation and what technologies are available there for us to be able to essentially make these projects a reality. And then obviously the offshore cable technology with what is being considered right now as floating cables. Next slide. So just to wrap this up, wanted to kind of show you guys the Humboldt Bay and the Morro Bay call areas. The way it's being set up right now currently with BOEM is the different colors essentially indicate the different solicitations that we're going to see. So that particular for Humboldt specifically, you're going to have essentially two developers or two entities essentially having a chance to actually win that area. And then same thing for Morro Bay. That is being broken out into 3 pieces. The both of them together are about 583 square miles as estimated, and we're expecting to have all of that essentially transmit about 10 gigawatts back into the grid. Next slide. I think with that, I will pass it back to Scott to talk about the comparison with California to Maine.
Very good. Yeah, thank you, Milad. So I figured, we'd kind of close this out with how does this all compare to, where we are in Maine and the tale of two coastlines, if you will. And really the biggest comparison that I like to start off with is the water depths, and they are similar but different. And the similarities are, just the depths that they get to are at depths that are looking like you need to get to a floating technology, both floating for the wind turbines and potentially floating for the substations as well. The differences between the two is that California really does drop off quite quickly from shore, and the depths that the California coastline, particularly these different call areas, can get quite deep. 1,000 feet. To over 3,000 feet, particularly in the Morro Bay area. And how I remember it is Humboldt's kind of in the Northern California section. Morro Bay is more, I guess, Central Coast is what they call it. So although they're deep, California is definitely much deeper. Whereas in Maine, and it depends on how you draw the circle around the area of the Gulf that you're looking at. But, generally speaking, you're in that 200 to 600 foot range. It's a large Gulf, obviously, and that does go up in some particular spots. But that's kind of just how I like to draw a general circle around it. And like I said, it is more gently shelving. It doesn't drop off as significant, which can be helpful in some senses, compared to California. So I did talk a little about the floating offshore design comparison. So this is something that I pulled from a Mitsui report, which I thought gave a good picture of the different types of floating technologies that are out there. And that's really broken up between the substructure that we have. There's also a call out to the dynamic cabling, which is very important with floating designs. And And when I first started getting into this, when I thought dynamic cabling, I was thinking from the electrical concept, but this is really from the mechanical concept. So allowing the cables to kind of move, if you will, with the currents, with the waves, in such a way that the cables do not degrade from their mechanical properties. And that dynamic cabling adds some, complexities to the design of those cables that need to be accounted for, and need to, progress as you get deeper and deeper. And the types of cables carrying this power, they get larger and larger due to, kV levels, the voltage levels, the power that it's carrying, so on and so forth. Another important part is the mooring lines, or basically how they're attached to the ocean floor, as well as the anchors. Again, with these depths, it becomes more challenging in terms of making sure that all of these components work together. So there are various designs out there. I believe that there's a lot more kind of in the R&D stage. These are the main ones that I've seemed to find as I've done some research in this area. So, as I mentioned, the floating wind turbine and floating substations is a challenge and something that needs to happen. The floating substations are generally mature. There's been a lot of experience gained especially in the oil and gas industry, where they have put their platforms in very deep water. They have large, what they call steel jackets that can connect down at very deep points of the ocean floor that could be used from a offshore substation design perspective. Of course, it all comes down to cost and optimization of all of the components that come into it. So that's on the substation side of thing, or what I like to think, where all of the cables may come together to step up the voltage, say from the array cabling from the wind turbines to the export cable voltage that would be needed to bring the power to shore. And then you also have the wind turbines themselves. So, typically around that offshore substation, you'll have little arrays or could be daisy chained, for example, of wind turbines that are aggregated and collected up to the substation level. Those, I think, in both coasts are very much so going to need to be the floating turbine design. There have been a lot of technology advancements in that. We have some sample projects that are out there. So that is moving forward, but obviously in a large scale of things, that will all change. So that's on the floating wind turbines. Reactive compensation is another thing that's important. Basically, underwater cables, the cables that are used to bring the power to shore, they do create a charging current that needs to be offset in order to maximize the use of that cable for the real power. Over long distances, that charging gets greater and greater, and obviously it needs to be offset, and that can be done with what they call reactors, or I like to think of it as a megavar load, if you will, that can either be put on the ends or could be done in the midspan. So depending on the distance of shore, from the shore you may need that midspan reactive compensation substation, which again, depending on the depths, could lead you into the floating or fixed bottom need. And obviously the longer the distance and the higher the power, the more that becomes important. Finally, cable technology, which we touched on a little bit as well. The use of these dynamic cables at higher voltage levels. There's really not a lot of experience out there. We are getting there, and cable companies are definitely looking into it. They're at a kind of an immature stage, if you will, in terms of actual commercial development, especially at these larger kV levels. There has been some use at lower kV levels, especially in the oil and gas industry, but that will continue to evolve as we go. So, one of the things I like to make that comparison with Maine and how California can kind of help is that, that's going to advance the development and really commercialization of these technologies. And given that California is kind of at the earlier stages, if you will, of the lease, the BOEM lease stages, that is just going to push that technology further and further. And that's the same for the floating offshore substations as well. So really, these challenges do exist, but they can definitely be overcome, with the industry support and as the industry matures, just like we have always done in the past. So the other good comparison between the two coasts, if you will, really is the wind speeds. The reason why these areas are looked upon as high potential for offshore wind is the wind speeds themselves. So in this slide here, you probably have seen it before if you've been following the industry, and really the northern coast of California and the Gulf of Maine both have excellent wind speeds. The red here, just in case it's a little small to see, is in that wind speed of about 9.5 to 10 meters per second at the 90-meter hub height. And that's really good. Basically anything over 7 to 8 is good. So obviously this is much better, and the two are very, very comparable. The next slide here that I have kind of zooms in a little bit so you can see in a little bit more detail. Gulf of Maine on the left, California on the right, and you can see how those wind speeds are comparable. Just general numbers here that I like to look at. I was looking at an NREL report that showed the Gulf of Maine has about 100 or so square kilometers of federal waters that have wind speeds over 7 meters per second. And kind of a general rule of thumb, that could equate to about 500 gigawatts of offshore potential. Of course, there's a lot that would need to happen for that to be built, and it probably wouldn't all be developed. You need an energy demand for that. Obviously there's a lot of restrictions out in the water of where you can and cannot put things. But just in terms of scale, I thought that was a good, ballpark to show you how big that is and how much that could equate to. So in summary here, just, kind of the comparison of the two. We do have, the wind speeds very comparable. Water depths, it's definitely deeper in California, but it doesn't change the technology needs. Station platform types, California, it's pretty much all floating. In Maine, it could be floating. It could also be fixed depending, there are fixed, I'll call it substations, depending on the locations of them and where they are in the Gulf. And then, distances to the coastline, obviously depends on where things are built, but they're fairly comparable. So, and that's just the coastline. The point of interconnection is really what would drive the design. So depending on how far south you go or north, that will all dictate kind of the overall design and what would be needed for this offshore farm. But as a crow flies, if you will, they are fairly comparable. So with that, I will end it up. And Marty, I think I did pretty good on time here. And I'll open it up. And I guess, Paul, if you want to, how do you want to do questions?
Yeah, you bet, Scott. Thank you, Scott and Milad, for walking us through that. Yes, let's dig into some questions and do some further conversation. First, I, want to kind of open up the discussion as far as the involvement in the offshore oil industry. We're seeing more and more involvement on the East Coast with the offshore oil companies, the large oil companies now partnering with and being part of some of the offshore wind development. California has an offshore oil industry that's already operating and in place, whereas many places on the East Coast do not, other than kind of the Gulf area. Milad, I think this is really a question for you. Is the presence of the offshore oil industry actually being in California offer an advantage as there's continued development and exploration in this market?
Paul, thanks for that question. As of right now, I think everything's kind of on the table. The technology challenges are real. So we're, as far as it's concerned, I think we're looking at everything and anything that's a viable option. Obviously, the oil industry is a little bit more aggressive with what they've done and essentially have gone to the bottom of the seafloor for their industry. What we're trying to consider here, and there's a big piece to this that has to do with actually a California Public Commission and the CEC, is offshore wind is being looked at the same way solar is, and in terms of essentially a renewable generation add. And what's happening is they're considering the two as on par in terms of cost. So if there is a requirement to essentially add generation, the cost of it needs to be comparable to, for example, the next leading technology, which is solar, and we all know that's going to be vastly different. So for as far as the industry is concerned, they're trying to work on the floating, so we don't have to go all the way to the bottom of the seafloor. That obviously will help save a whole lot of costs for us, and make the offshore wind more palatable for the public.
Thank you, Milad. And just as kind of a follow-up to one of your comments there about the diversity of fuel sources. In one of your earlier slides, you did mention some of these resources going into storage. Is there an ongoing discussion within the California market for some of these resources going to hydrogen? Or is it still too early for that?
No, absolutely. Hydrogen is a big piece of this. We are the reason that everyone talks about battery storage is because it's more of a proven technology and it's further down the pipe. Hydrogen is definitely part of the consideration here. Unfortunately, the technology hasn't evolved as fast as we want it to, but we're hoping that this happens very soon. We're very active in the hydrogen market as well. And like I said, at this point in time, with California specifically, all hands are on deck. Everything's being considered and everything's being looked at.
Sure. Let's kind of dig into, we got a number of questions on really the infrastructure, the cabling, and the transmission build out in California. So I'm going to try to lump some of these questions together as kind of a bigger subject. Can you please just go back and describe a little bit more how the backbone system is planning on operating? Are these backbone systems that are really going to be looking at each individual area, or is there a full system going to the coastline of north and south coastline of California? And then go a little bit further to how you expect those to be installed, what the coming onshore landing is like, and what those cables look like as they come onshore and then interconnect to the grid, and then who's going to be owning and operating those systems.
Okay, so that was a lot of questions you lumped into one. So I'll do my best, and I'll probably pass it on to Scott to answer some of those. In terms of what California ISO does on an annual basis, they essentially have rate cases and generation planning that they do about 3 to 5 years in advance. So a lot of this stuff, I know I saw the question also that, was the transmission an afterthought? Typically, no. There has been a lot of pressure, like I said, from all levels of the legislation, to try and include offshore wind as a piece. As mentioned before, CPUC maintains its position of you need to be comparable to the next renewable source, and there's no need for us to pay extra. So, offshore wind is included, but if the price doesn't make sense and it will put pressure on the ratepayers, the CPUC will pivot. In terms of, so that study that CAISO does also includes, also identifies any gaps that they have in terms of transmission. So for example, this 20-year plan, it was exactly done for that purpose of, I have 10 megawatts of solar that I'm sorry, offshore wind that I'm trying to put in here. We're also adding about 50 gigawatts of solar in here. Where are those going to be co-located? Where are the gaps within our transmission system? And the result of that is a whole bunch of new transmission lines. As I mentioned to you guys, north and south is definitely one of the ones that they're trying to double up. There's another east and west along the Highway 10 that they're also trying to duplicate as well, because that particular line also runs very hot within California. In terms of the technology coming onshore, Scott, I'll pass that on to you in terms of what you've seen so far.
Sure. Yeah. I mean, to get the power to shore, obviously, there's lots of different ways to do that. AC versus DC is primarily the discussion that comes up there. Distance and amount of power being carried is really one of the main drivers, as well as just the cost comparison between the two. And then there's different types of designs that have been contemplated out there. Obviously, you've probably heard of what they call a mesh network, or something on the wet side of the offshore wind development side, where you could have shared, I'll call them export cabling systems going to shore amongst many developers that could be owned by a transmission owner or something else. And really what you're getting to there is the cost allocation, which is really a tough nut to crack, if you will. There's been a lot of discussion about how that could be done, and it seems to vary state to state. New Jersey's got an interesting way that they're looking at it with the state solicitation that's going on. There's also some examples, and I actually just read something recently. Apparently there might be some talks about doing that in Massachusetts. I don't have a lot of details on that, but I did hear kind of a separation between the G and the T specific to this. So still a lot to be done, especially on the cost allocation side of things, and who's going to be owning that equipment. And that all becomes more important as you start to look at wind farms really working together, sharing their connections to the grid, and really having that offshore portion being integrated as part of the grid. So really the answer is still more to come on that one. The transmission is definitely needed, as well as the energy demands. So once just having the power is one thing, but it needs to be able to get to the load. And looking at that holistically is a very important component to making sure we're getting the best use out of these facilities.
And can either of you answer the question, what length, the cable length, where reactive compensation becomes a concern?
Yeah, and the easy one to that one is it depends. But there's some general rule of thumbs there. So the higher the kV level, the more charging you have. And then the more charging you have, obviously that's when you need that reactive compensation. So it is going to depend on the kV level. Also the size of the cable itself, the larger the cable, the more the charging. So, and the larger the cable is needed to support more power. So those factors that go into that are both length, kV level, and amount of power being put in there. But I mean, if I had to put a general rule of thumb out there, 30 to 60 or so miles, you need to start looking at that reactive compensation, especially where it is, matters, and so on and so forth. So that's just kind of a general ballpark, but obviously there's a lot of factors that tie into that.
And then and some of the routing questions and permitting questions associated with the cables in particular is, there's marine protection zones in California, and quite a bit of those. Is there the understanding and the partnership within the state that there, with proper siting and procedures, those types of activities will be allowed in those types of zones?
So
go
ahead, Scott.
I was going to give it. Yeah, no, I was going to give it the main flavor, if you will, because I have been kind of watching how the small zone that's kind of out there for one of the ongoing projects has evolved. And what I saw, or just recently, I saw a slide that looked. They started off with a large zone of where they might want to look at putting this offshore wind farm, and then it seems like they went to different stakeholders, different groups, and kind of ended up narrowing that down to a specific portion of that area, which would then be used for the offshore wind facility. So, I think, from a permitting perspective, there's always going to be permitting challenges, but as these zones or areas, these lease areas develop, the involvement from all of the, concerned stakeholders and people that are involved with this really just helps make those come to a point where most can agree, if you will.
Milad, did you have something else to add to that?
No, I mean, he covered it quite well. I mean, it's an ongoing discussion. That's pretty much the short answer to that. So, but he covered it quite well.
So we do have a question about the Diablo Canyon nuclear power plant and the effects that may have on this entire plan and outlook, in particular for Morro Bay, should it not shut down?
Very interesting question. For the time being, there is no plans for nuclear in California. So whatever is there that's operating will be shut down. And whatever is shut down will remain shut down. My personal opinion differs, but that's not necessarily a popular one.
And just from a pure call it point of interconnection planning perspective, obviously if there's a large facility at a node where injecting power at a node, that would limit the ability without any changes to the grid to bring other power into that node.
Thank you. How would you compare the site assessment, environmental assessment, and future impacts monitoring, and so on between the two states? Because this is really in BOEM water, should we expect similar treatment on both coasts?
I would imagine from a BOEM perspective, and I'll let Scott talk about this if he's got a comment. From a BOEM perspective, it's not. I don't think it's that big of a change. What happens is as you approach the coast and the different legislations and different stakeholders become involved, I think that's where you'll see predominantly the difference.
Yeah, and unfortunately, my background's more on the electrical system side of things, so I really don't have an answer to that one, other than the more people involved, the better, early and often.
And Milad, do you have any insight? I don't know if you are fully versed in kind of the character of the Maine community, but do you have any insight on how the community kind of outlook of California versus the Northeast might be different when you get into those local conversations with cables coming on shore and state involvement?
So I don't really have any idea of what's happening in the Northeast. I'll be honest with you guys. So my experience has so far been within California, but I mean I'm pretty sure the state, and by that I mean California, has developed a reputation for being difficult to permit anything. The state legislation is kind of moving towards trying to ease that, but obviously conversations need to be had with different stakeholders, and agreements need to be had. So I know there's there's labor laws out there. The union is also trying to get ahead of this thing from a West Coast perspective, trying to get in front of this to make sure they guarantee some work for themselves. Obviously, each local jurisdiction, as they have their say within the project, they will try and carve out a little piece for themselves. But like I said, this is all kind of all developing. There's lots of good conversations being had, but nothing right now that says, what this is exactly the direction we're going. And in terms of a comparison to Northeast, like I said, I wouldn't be able to comment on that.
Kind of looking more specifically at the projects themselves, and I think this question is both kind of up in the air for both Maine and California. But are you aware of what is expected to be allowed for other marine traffic and activities within the project areas themselves? Will commercial fishing still be allowed? Recreational traffic, that type of interaction be allowed within those areas?
So two-part question. So obviously they're leaving shipping lanes out there. That's part of BOEM's plan. That's part of what we've been seeing out of in the East Coast as well. There are shipping lanes for people to kind of the ships to leave the coast and come back. We don't expect any interactions there. And then more on the technology side, as these dynamic cables and floating wind farms and substations are developed, a lot of these will be sitting, specifically the cables. I know there were some concerns there. The cables are going to be sitting, 300 feet down below the water surface. It's not necessarily on top, so we're not expecting any conflicts there with fishing.
Well, we've covered a lot of ground here, but we are kind of running out of time, and so I thought we'd kind of allow you each to kind of provide a closing statement before we go back to Marty. So if either of you would, or both of you would like to provide a conclusion on today's conversation, that would be helpful. Thank you.
Yeah, I mean, I'll start. I'll just say that, it's very exciting to watch things progress and watch how this industry has evolved over the many years. And it is, continuing to pick up speed. So, I'm just excited to kind of watch how it works, on all coasts and, see the advancement of this technology specifically and how it impacts the grid.
Milad?
Yeah, and I essentially echo that sentiment over here. We're very excited about the technology. We're very excited about the direction that we are taking in California towards betterment of the world and being in line with carbon neutrality and making sure we don't affect we don't have a negative impact on the climate going forward, hopefully. So we're very excited with that. I like our California's aggressive goals. I think it kind of creates a pressure cooker to make sure technology moves fast when you have legislation behind it. And I'm very excited about that.
Well,
This is wonderful.
thank you for your enthusiasm, and thank you both for your time today. Marty, back to you.
Well hosted, Paul. Great questions. Milad and Scott, thank you. Thank you for the idea for this presentation, by the way, to the team at Burns and Mac. I think this is so neat that we have a member with this presence on both coasts, so we get this cross-pollination. I learned so much, and this is just kudos to you. This is a really, really good presentation. I have just two things to tell you. One is that we will send you the recording. We'll also include a link to Maine's current offshore wind planning process. I think many here are involved, but just to make sure that we have that. And then I want to tell you that a week from today, we have a really interesting presentation from Dr. Daniel Nocera, who is from Harvard. And that is 1 week exactly from today about the bionic leaf. And then we've got a little networking thing put together in 3 weeks. So make sure that you sign up for that. No program, just networking, maybe diving into these topics with your friends and colleagues at E2 Tech. So I bet everybody's got a hard stop at 1. We need to grab a coffee and get to our afternoon. I look forward to discussing this further with you in more depth a week from today with Dr. Daniel Nocera, or at a networking event in 3 weeks. Have a wonderful afternoon. Thank you for being a member and supporter of E2 Tech. Enjoy the afternoon.
Thank you, guys.
Cheers.
Thank you.